So to find an antiderivative, we can go term by term. We can evaluate the indefinite integral. But if we evaluate the indefinite integral of 1/8 e to the negative 9x, we can remember that the derivative of an exponential function is itself times the natural log of the base. So natural log of e is just 1. So the derivative of this term would be itself, except we need to also apply the chain rule. If we were to take a derivative, the negative 9 would come down and multiply, because that's the derivative of the exponent. So we're working in reverse. We're doing the antiderivative. So the antiderivative should be negative 1 over 9 times 8, 72 e to the negative 9x. Because if you take a derivative of this term, it's itself times the derivative of the innermost function. And if you multiply by negative 9, the negative times the negative makes a positive. 9 over 72 is 1 over 8. So that's the antiderivative of this term. Okay, so it's a bit tricky. That's why they gave you a formula up here to work with. But remember, an antiderivative is something whose derivative would turn back into your original expression. And this derivative would turn back into this. And then the derivative of sine is cosine. But the derivative of cosine would be negative sine, right? So we can't just say plus cosine. That's not quite correct. Because if you take a derivative of this term, derivative of cosine is negative sine. We need it to be positive sine. So the antiderivative of sine of x would be negative cosine of x. And then there's some arbitrary constant c here, because you can take a derivative of this, and it turns back into this. But if you take a derivative of this and this plus 1, it still turns back into this. If it says plus 5 or minus 2, the derivative of a constant doesn't change the antiderivative, right? So that's why we need that arbitrary constant c.